Good afternoon, and welcome to Is Big Data a Big Deal or Not? A complimentary webinar from HealthSystemCIO.com, sponsored by Health Catalyst. Just a little housekeeping before we get started. My name is Anthony Guerra. I'm the editor-in-chief of HealthSystemCIO.com, and I'll be your moderator today. We're going to encourage you to ask questions to our speaker today. You can type them and send them in at any time in the Q&A box in the lower right-hand corner of your screen. Leave the default set to all panelists. We'll take those later in the program, but send them in as they occur to you. Download the deck. You've got the URL in front of you. I've sent it out in the chat box, and if anybody else needs that URL again, just send me a message. And you also have a shortened URL at the bottom of each slide. We are recording today's event, and we'll have that archive available shortly. So just keep your eye out for an email from us that says it's ready, and we'll put that on our YouTube channel. So you see how we're going to spend our time today. First, we're going to hear from my good friend Dale Sanders, EVP of Product Development with Health Catalyst, and then we're going to have our Q&A with Dale. So without further delay, I want to turn it over to Dale Sanders. Dale, thanks for joining us.
Thanks, Anthony. Appreciate it very much, and thanks, friends, for sharing your time today. Hopefully, it will be a good use of your time. I will do my best. I just want to mention that I was just doing the math as we prepared for this morning. 20 of my 32 years in my professional life after college, 20 of those years I was a CIO, and 12 of those years, most recent past 4 years, I've been on the vendor side of things as a consultant or a product development person. But my DNA started as a CIO in the Air Force, and so that's the perspective that I bring to today's discussion, assuming that most of the folks in the audience have a CIO-type responsibility or background. And answering this question about whether big data is a big deal or not and exactly what the heck is big data, I come from that perspective, and so hopefully trying to add some clarity to that, to the hype that exists around that term right now. And the hype really started, the term emerged, as far as I can tell. If you go out and look at the appearance of big data as a term in Google search engines and things, it started to show up about 10 years ago, which is further back than I realized. And it emerged at about the same time that the need for greater scalability in Silicon Valley started to rear its head, right, where traditional relational databases were not sufficient enough to handle the volume and the velocity and the variety of data that Silicon Valley was seeing. Prior to the emergence of, the Yahoos of the world and Googles and eBays and those sort of environments, the largest computing environments in the world at that time were in the U.S. military and U.S. government, NSA, and the intelligence community. But now those environments have been eclipsed by the commercial products that Facebook and Google and others offer. And so they were actually the first companies to run up against the problem of traditional relational databases in terms of their scalability and their performance. And also just the pure licensing costs of those relational platforms were not scalable as well, affordability-wise. So that's how it all started to emerge, and then this term big data started to come up, and a lot of times now it's being used as a synonymous term for data warehousing. In the background, that's still what it's all about. It's still, fundamentally big data is still about data warehousing and the accumulation of lots of data into a big repository for analysis. But the old design of, separate transaction systems and separate analytic systems are starting, those boundaries and those lines of distinction between those two worlds are moving away. And so big data now is becoming this term that encompasses not just analytics, but the combination of analytics and decision support embedded in a user interface that's typically around a transaction. And so if you look at the way, and I use Amazon as an example all the time, if you look at the way that Amazon presents the information to a user about a transaction, most of that screen space now around a transaction in Amazon is actually about the analytics of the purchase that you're about to engage in. It's not about the specific transaction. So that's one thing that I'd like to leave behind today is that we start thinking in healthcare about the merging of these two worlds of analytics and the technology of big data with decision support, especially around EHRs at the point of care, and start blending those two together. This is one of the areas that I'm really grateful that I started my career in healthcare at Intermountain, because Intermountain was doing this before even Silicon Valley was doing it, right? Merging decision support and the analysis of data in the back end with encounter-specific data about patients at the front end. Okay, so with that, let's talk about why it's important to know about this today, friends. And this is mostly intended a message for the other C-levels in the executive suite, not necessarily the CIOs. I think CIOs have recognized this for a long time. The other C-levels, I don't think quite appreciate this yet about healthcare, and that is you are in the technology-enabled services business. Everything we are trying to do in healthcare is either enabled or hampered by software. So like it or not, CFOs, COOs, CEOs, your business now runs at the speed of software. And I use these examples in the bubbles below to highlight just how important that concept is and how every C-level in every executive team, not just the CIO, has to be a technologist now. Every C-level has to be a little bit of a CIO as well. Healthcare.gov is a great example of how disconnected executive leadership was from the realities of technology, and trying to implement the policies and the aspirations of the Affordable Care Act in technology was orders of magnitude more complicated than what executive leadership believed that it would be. And it almost took down an entire national healthcare policy because of that disconnect between what we want to do with a policy and what we can do realistically in a reasonable period of time with technology. Of course, the adoption of EHRs has been a big impact on the industry. The use of those EHRs in a meaningful use environment. We're now struggling with care management, and what does that mean? What does patient engagement mean? All of these things now that are affecting the industry at the highest levels of the executive team are all technology driven. And so it's really important that the C-levels and CIOs in particular have a grip on the technology that underlies all of this. And that's why this big data topic is so important. You have to understand these things to make the right decisions. And I also want to sort of issue a call to arms, if you will, that I believe that healthcare providers are really the only entity that are currently capable of changing our system. They're the only place in this ecosystem of organizations and people affected that can really drive the change that the U.S. healthcare system requires. Payers, not so motivated, right? Because if we continue to rise in expense and consuming our GDP, payers just keep pushing that cost off to providers. They push the risk off to providers. They push it to patients. They push it to employers. So payers aren't all that motivated to change this model. And oh, by the way, changing their transaction-oriented information systems that are still built around fee-for-service claims adjudication is going to be a big change for them. So even if they change their culture and their mindset, payers are going to face a pretty big challenge in re-engineering their claims-based, fee-for-service-based claims adjudication systems. Patients don't know how to change the system. They don't understand the technology that can change it. They're just hoping that someone can change it. Employers are in a little better position to change the environment, but again, they don't necessarily know how to affect the changes in the healthcare system that are required. Providers sit at a very unique position, and so with the application of technology, providers can actually bring to bear the knowledge about the market, what needs to change, as well as the actual ability to change. All of those come together at the provider level, and so that's the key to all of this, is the providers taking the reins. A lot of times I look around and I feel like our whole industry we're all waiting for someone else to change, right? We're all kind of looking left and right before we step out. But courageous providers and healthcare systems and integrated delivery networks are in the best position to do this, and they can do it through technology. One thing I want to mention, friends, this proprietary and confidential label that's at the bottom of these slides is inappropriate. None of this is proprietary or confidential, and we'll remove that and make sure that folks can download these slides and reference these later without any concerns about that. I like this slide. We won't go into a lot of detail about it. I just like the way that it creates a juxtaposition between the old world and the new world, right? Healthcare 1.0 and Healthcare 2.0. The difference in expectations that our parents had versus our children. And the bottom line is it's changing, and technology is the way of the future for all of our children, right? I have a 19-month-old little girl, and I try to keep her away from our iPads and iPhones and Androids and things to the degree I can, but every time she gets her hands on it, she's interacting with it, and she can navigate around an iPad now as well as I can. It's pretty amazing. So technology is at the core of this, and the culture in our healthcare society is at the core of this change as well. So this is just a fun slide. I encourage you to take a little more time to use it and think about it later. One more aspirational call to arms that I'd like to drop with the audience, and that is that change comes from the margins. And I love this quote from a professor, Kostka Broniton at Texas Tech University. He was actually talking about the rise of dataism as an art form in the early 1900s. But it applies to every change in every industry. And I'll just bear with me, so I'm going to read this aloud. You signal your determination to belong to the center by unreserved confirmation to its standards. For all these elaborate protocols are also meant to ensure that not everybody gets in and that enough are left out. This way the center makes itself perpetually desirable. Since most do what they can to keep their place within the status quo, far-reaching innovation is usually discouraged and conformism rules. And as I go across the country now, friends, and I observe what's going on, I see a lot of folks on the left side of this cartoon here feeling like that change is being forced and imposed upon them. And I would argue that they are going to be the marginalized. And I think 90% of healthcare providers are in that realm right now. They're waiting for change to be forced upon them. And I would encourage all of us, right, to be the margin, to break the mold of the center, act like patients that we all are, and change the system from within. And we can do that through data, and we can do that through technology in ways that have never been possible before, through transparency of quality, transparency of pricing, and sharing the knowledge that a lot of patients haven't had in the past to make informed decisions. We can now improve that. So try to break the mold, try to get outside the center, and if you feel like you're part of the center, get out of that center and encourage challenge from the margins. We're just now in the next slide here depicting the ecosystem of healthcare data. We're just now at the beginning of this, right? The reality is healthcare encounter data only captures one tiny little snippet of the digital form of healthcare and a patient's profile. I bet I've been to a physician maybe 4 times in the last 10 years. So the digital representation of me and my health amounts to very, very small data. There's no big data about it. But as we expand our understanding of healthcare, we have to expand our grasp of data that rounds out that digital form of the patient. So to get to precision health, we have to start plotting these strategic data acquisition timelines for getting our hands on biometric data, outcomes data, consumer data, genomic and familial data, and social data. That's going to round out our understanding of healthcare and a patient's overall health status. As a CIO, I would calculate the amount of storage that I required every year for patient data in our EHRs. And the number hasn't changed much in a long time, and that number is, I plan on about 100 megabytes of data per patient per year, okay? That's how much storage was required in the EHR on average, 100 megabytes of data per patient per year. That's not very much data, friends, right? That's a handful of songs. And the truth is there are patients that have lots of data associated with them and patients that have very little data. It's that dark matter of data about healthy patients that we need to start collecting because that's our target data set for analysis. So healthy patients who have the smallest data footprint in our current systems are those patients that are going to teach the algorithms that we need to apply to the patients who are less healthy. But we're not collecting that data. I just flew home from Nashville last night on a 757, Boeing 757, and that aircraft collects 500 gigabytes of flight performance data in a 6-hour flight. That's where you start approximating big data. But right now in healthcare, we're not big data because we're just capturing these thin slices of episodic data. So we have to get out into the non-traditional forms of data collection if we're really going to get our arms around patient health and affordable care. And I might also add that, you know, a lot of these, you could argue that the 7x24 biometric data is pretty steep, and that will constitute pretty heavy data volumes. I think there's still a fair amount of debate about whether that's going to be valuable or not and how we're going to even consume that and make sense of it. If you look at the risk factors to care, it's 80% of the risk factors to care fall outside of the traditional care delivery network. So only 20% of the total healthcare picture that we look at right now is actually attributable to traditional healthcare delivery. 80% of our risks come from socioeconomic factors. And there are only a handful, maybe 20 data elements that we need to collect in a socioeconomic environment that would have huge value algorithmically in our ability to predict and understand and prescribe better medicine, right? So that's small data. Literally, only about 20 data elements are required in that socioeconomic environment to better inform the delivery of care and the management of care of patients. So even that is not big data. It's relatively small data. In fact, it's very small data. So those of you who know me know that I advocate this concept known as late binding in data engineering. The Hadoop world calls it schema on read, not schema on write. And what that means is basically you're going to consume data in its raw, natural form. You're going to dump it into a repository in that raw, natural form. You're not going to change it much at all. And you're going to bind it to clinical and business rules as you pull the data out. But you're not going to impose those rules when you write it in. And I've called that late binding. As I mentioned, the Hadoop folks are calling that schema on read, not schema on write. But everyone is now realizing that there's no such thing as an enterprise data model that can stick around for very long. Old school data warehouses were built around this notion that you can completely model in an enterprise fashion all of the data that's ever needed and ever will be needed in a healthcare setting. And that's impossible because as soon as you get those enterprise data models finished, they're outdated. So you can attempt to model most of what you understand, you know, the healthcare information, the HL7 RIM, the reference information model, is a pretty good data model for generally describing the kinds of data that we currently collect and interact with in healthcare. But it's also fairly old, and it doesn't accommodate the new emerging forms of data well at all. So modeling your data a priori and assuming that you know your entire environment is a falsehood, and it's been proven over and over you can't keep up with those data model changes. And the Hadoop, those young kids that created Hadoop saw that early on. And so Hadoop is naturally, in the big data environment, are naturally late binding. They were designed with no schema in mind until you read that data out. And so it makes itself, the platform of Hadoop and the platform of big data makes itself more amenable to the rapid changes of healthcare data that we're facing going forward. So I encourage everyone to dismiss yourself of the notion that you can create an enterprise data model that will last for any longer than the data modeling exercise. As soon as you publish that thing, it's going to be outdated, and you'll never be able to keep up with all the mapping and the modifications to that data model to support the use cases of analytics that are facing us in today's environment. So we're in this interesting world, right, of the big data world of Hadoop on the rise, feeling a little bit early, and clearly the decline of relational databases for analytics on the downhill side of that. Now, companies like Microsoft are doing some things to extend the length of that curve a little bit. That's the trailing L there, by partnering SQL relational databases up against the Hadoop platforms. Microsoft calls this the advanced analytics platform. So they're doing some things to extend it, but the reality is relational databases from an analytics perspective are on their way out. As a CIO, though, they're not so far out that you can toss them aside, right? And but you can't keep binding your entire future to a purely relational database platform. You have to have some sort of strategy and transition to start taking advantage of Hadoop. I'll go into the timing of that later. But we are definitely on the upswing of Hadoop and on the downswing of relational technology. And I'll share with you why that's the case here in a few more slides. I won't go into the details of this slide, but it's a great slide, and I credit the folks here that I borrowed this slide from. Great summary of the analytics evolution over the last few years. I added Spark to this. Spark has emerged over the last 4 or 5 years as a great both alternative as well as an add-on product to the Hadoop platform and Hadoop stack. I just have the enormous respect for what's happening in the open source community around Hadoop and big data. The acceleration of great ideas and great products that are commoditizing this incredible technology is unlike anything I've ever seen in my career. It's one of the coolest things ever, and it defies all traditional definitions of economics, frankly. When you see all of the supposed competitors collaborating and contributing to the evolution of big data platforms in an open source way, yeah, I don't think you'd ever predict it from a traditional economic model, right? But it's certainly displacing the IBM DB2s, Oracles, and Microsoft SQL servers of the world. Those products are going to have to figure out a way to compete at a commodity level in the same fashion that Hadoop and the other big data platforms are, or they're going to be out of business in a couple of years. So this is just a cartoon that I drew that describes, you know, what precipitated the problem with these relational databases, and why did the big data platforms at Silicon Valley finally say, we can't keep doing this anymore. And interestingly, it became largely due to networking issues as much as it did anything else. And this diagram shows that, you know, if you're going to do a full table scan from an analytics perspective on a 1 terabyte table at 100 megabits per second, it's going to take you 167 minutes to process that. That's going to make for some unhappy data analysts. So in addition to the scalability, the performance, the affordability that Hadoop and the big data platforms allow for, it was getting past this bottleneck, which amounted to, you know, a network throughput issue that was a big part of the problem and the challenge. So in the Hadoop world, you spread that data across all sorts of utility-based, very affordable disks and servers. So that's kind of the mapping process, right? You're shoving all of that data across, and you're spreading it all across these very cheap and utility-based computing platforms. And then you're bringing it all back in through this map-reduce window when you run queries and process against that data. So and this is the Hadoop distributed file system that I'm depicting here on the right-hand side. So that's the whole map-reduce thing. When you hear people talk about map-reduce, it's mapping all that data out to these highly redundant, very cheap, very affordable servers and storage systems, and then reducing that all back through the window at query time. And it's, you know, I don't want to oversimplify it. That's the big challenge, right, is this technology is so different and the skills are so different. That's one of the things that's standing in the way of this technology being more commonly used right now. This is not easy to do technically, but in recognition of that challenge, the open source community is building all sorts of cool tools to make this abstraction between data and the user through newer and better versions of what amounts to MapReduce and concepts similar to MapReduce. That's progressing as well too. So the knowledge base is starting to squeeze down. So, you know, what's compelling, right? I won't go into the details of the slide. All of these are kind of there for your reference later, friends, but the volume, velocity, and variety of data is what created the compelling use case and demand for this in Silicon Valley. So one of the interesting things for data modelers out there is that Hadoop is basically designed around key value pairs instead of relational data. EAV, entity attribute value model, is basically what it supports. Those of you who know, you know, Stan Huff at Intermountain, he's a big advocate of the EAV model. It has some drawbacks, but it has some significant benefits if you're trying to model non-traditional forms of data. And if you're trying to keep up with the variety of data that's coming into an organization without binding that to a relational model, EAV models are the most appropriate and flexible. In the Hadoop world, you're using declarative, or rather procedural programming more than declarative, so SQL programming versus Python and Java and .NET. You can do more and powerful analytics with those procedural programs, which is the way of the future. SQL will always be around. It's going to be around for a long time. It's very powerful for some things, but it has significant limitations in terms of its ability to, you know, process data from an algorithmic perspective. So again, I won't go into all of these different things, but licensing savings, granular security. One thing I might add is that, you know, the Hadoop folks grew up in a post-relational world. And so they had the ability to kind of step back and say, not just at the technical level, but at the data management level, what did we learn in relational databases, good and bad, that we should take and carry forward with Hadoop. So much better security environment, much better thought out in terms of role-based access control. Optimization of these databases and these platforms is a lot more granular and easy. It's really become, the Hadoop ecosystem has become an operating system for data management is what it amounts to, including tools for data governance. So it's not just a database anymore. It's a whole ecosystem of tools for data management that looks like an operating system for data management. So that's the beauty of coming into this after the post-relational world is that these young guys and gals figured out everything that should have been done better by those of us who were in the relational world, and they've done a really good job accommodating that. And of course, they're much more capable of supporting unstructured text-based data and XML tag data than we were in the relational world. There are 5 pillars, and I'm using the Hortonworks data platform. They're a commercial vendor that is the purest form of the open source community around Hadoop right now, so I tend to reference their work most often. And these are the 5 pillars of tools and things that they offer around the open source community, and Hortonworks is adding value to each of these, but it's governance and integration of data, workflow and lifecycle governance being a part of it. So again, it's not just technology, it's the governance and the utilization of data and the tools to support that. Things like tracking the lineage and the sort of the genetic history of data is really important in analytics, and they've done some things with these tools to help track that lineage and collect metadata and carry that forward. Batch and interactive real-time data access. So, you know, in the old days, if you were running analytics on a traditional relational database, it was hard to update that database at the same time you were doing very big queries against it, right? It didn't know how to handle what we called then dirty reads. as the underlying database was being updated, it became very, very challenging to provide, accurate analytics and snapshot that data for analytics. Well, the Hadoop environment grew up knowing that real-time updates and big giant queries were going to happen, and the tools were designed and the environment was designed for that use case. Security is greatly enhanced and much better than what we've implemented in relational platforms. Operations of these products is also really improving. So the system management functions growing up considerably. And then, of course, the whole data management layer at the file structure layer, great tools for that as well. So pretty impressive work. This is the closest thing that I could find as an all-encompassing diagram of the Hadoop ecosystem. And by the way, the elephant, the story behind the elephant associated with Hadoop is that was the name that Hadoop was the name of a childhood toy from one of the founders of Hadoop, one of the original guys at Yahoo that took the Google white paper and actually turned it into a working technology. So they named it after one of their children's toys, which was an elephant named Hadoop. But these are all the different products now that are making up the Hadoop ecosystem. And as I mentioned, it's the community of Hadoop that makes the difference. It's not the technology, it's how you leverage the technology. That's the differentiator. So these folks are making this a commodity, knowing that it's how you leverage the technology that makes the difference. So it's going to be interesting to see how IBM, DB2, Oracle, and SQL Server at Microsoft react to this commoditization of this technology, because they clearly can't keep charging the kinds of numbers that they are charging for traditional relational databases. They're going to be squeezed out of the market if they do that. So as soon as I published this diagram, it was out of date, so I encourage you to go out to the websites here that I indicated in the upper left for updates. Gartner ran a survey in May of 2015, I believe, kind of what's going on in the CIO space. There were 284 participants in this. This was that survey's summary results, right? What are your plans around investing in Hadoop? No plans, half of CIOs, and this is across all industries, not just healthcare, half had no plans. Yes, but it's kind of in the experimentation phase. No, but planning to soon is in the 11% range there, and no, but ahead. So lots of folks still not quite convinced that Hadoop is worth the investment. I would say that for those who have invested, and it's not easy to invest because you have to transition a lot of skills, the payoffs have been pretty big. And this story about the conversion to Hadoop is going to become more and more compelling. So this is a pie chart that's going to change rapidly over the next couple of years. I've never in my career seen technology accelerate at the pace that this Hadoop ecosystem has. It's really fascinating, and it's also very hard to keep up with. But if you're in this 56%, you're in good company, right? Most CIOs are still sort of sitting on the fence about it, and I don't think there's anything wrong with that. It's going to be hard to sit on that fence for much longer than 2 to 3 years, though. The affordability and the compelling value that Hadoop offers is going to surpass, the ability to be indecisive. The reasons for, the challenges for adopting Hadoop are kind of the things you would expect. It's at the top of the list, obtaining the skills and capabilities needed. Now, there's some things happening in the Hadoop ecosystem that allow for the SQL-based skills in your staff to still be applied to the Hadoop platform. So there are these SQL translators now that are becoming more and more capable that allow folks to interact with Hadoop-based data in a non-SQL environment. Determining how to get value out of Hadoop, right now it's around scalability and licensing. I mean, it's orders of magnitude less expensive to deploy a data system using Hadoop than it is the traditional relational vendors. And then so on, the challenges of how to integrate this data. They have concerns over security and privacy, and I would say, this environment is a lot more amenable to high security and privacy than relational databases because it was built in from the beginning. Now, all this good news, right, about Hadoop, well, along comes a new thing called Spark. And Spark is interesting in that you can plug it into the Hadoop distributed file system, or you can use it as standalone. So that's the good news. Spark, again, kind of took advantage of all the lessons learned from the Hadoop ecosystem and made it a little bit better and made it easier to interact with, accommodated the skill set transition a little more effectively, and also did a really cool thing around its ability to support algorithms. And if you look at the future of analytics and decision support, it's really going to be around algorithms and machine learning, less and less around SQL queries into analytic systems, right? The future, the world around decision support is going to be in algorithms, not necessarily SQL programming. And Spark is specifically set up and designed well to support those APIs to take advantage of not only in-memory processing, but also algorithmic processing. So keep an eye on Spark. It is many, many times faster even than the pure Hadoop file system infrastructure because it all operates in memory. And there's a diagram of the Spark ecosystem that if you're interested, you can run it completely independent of Hadoop. The reality is it makes sense to use Hadoop because this Hadoop file system is so affordable and so scalable. So the best way I still think to run Spark is against a distributed file system that's Hadoop-based, but then applying these very cool ecosystems and APIs on top of it. So I want to skip here to a couple of use cases. I'm not going to go into these use cases, friend. I'm going to leave these slides for you to reference at a later time. I just want to mention that when you look at the use cases for Hadoop, there's nothing in particular that Hadoop can do or allows you to do that you can't do in a relational environment. It allows you to do some things, especially in an analytic world, that's easier to do in Hadoop than it is in SQL Server or Oracle or DB2. But the reality is you can do everything in the traditional relational database that you can do in Hadoop, but Hadoop makes some of those things a lot easier to do, especially when it comes to algorithmic programming and the ingestion of data on a rapid, high-volume basis, and the ability to read and analyze data while that underlying transaction system is being updated. But there's nothing compelling about these use cases that you'd say, wow, that's uniquely suited for Hadoop. You can do everything in these use cases in these slides in a relational environment. The compelling argument still is the cost and the affordability. That's the compelling argument. That's what you can't do yet in the relational world. And so again, it'll be interesting to see what Oracle, Microsoft, and IBM do in reaction to this. Because you could, if you lowered your price point, lower the compelling story and attractability of Hadoop. It'll be interesting to see if they do that. But you can see these numbers, right? I mean, it's crazy less expensive to implement things in Hadoop than it is in these relational databases. Okay, one more slide in this area, and this is kind of about the how you spend your money. So if you go back, let me back up to this slide. If you go back and you say, gosh, I'm paying $19 per gigabyte versus 23 cents per gigabyte for this infrastructure, then you would think out of that cost savings, I could afford to transition the skills necessary. And that's the mindset that I would have as a CIO. So even though it looks kind of ornery for you to leapfrog the skills barrier into Hadoop, there's plenty of cost savings to help retrain and hire folks who have those skills. And that's where I would use that cost savings to overcome that economic barrier of entry is really at the skills level. It's definitely not at the technology level. All right, the rest of these slides, friends, I'm not going to spend a whole lot of time on. Anthony, I would rather spend time on questions and some dialogue and that sort of thing. Again, leave all these slides for reference. I don't think you're going to see anything that's gigantically compelling in these slides in terms of use cases. You'll say, gosh, we could probably do that in a relational world. But you can't do it as fast and you can't do it as affordably as what Hadoop allows for. All right, so Anthony, I would think I'm going to turn it back to you with that, friend. Oh, okay, let me go through these lessons learned just to summarize things. So kind of, again, appealing back to your sense of courage. Don't be the marginalized. You know, step forward, encourage your other C-levels to take chances. Gosh, our healthcare system is in such a crazy, sort of sad state of affairs on so many levels. You know, making a mistake now, in a courageous mistake, doesn't have much downside, right? So don't be a part of the core. Be a part of the margin that changes this. Push these concepts into the rest of your C-levels. They have to understand that we're now in the technology-enabled services business, like it or not. Healthcare now runs at the speed of software. There's no question that the Hadoop ecosystem is revolutionizing data. I think you've got about 2 to 3 years before it becomes so compelling that you can't ignore it any longer. And just watch this Hadoop community. It's one of the most amazing things that I've ever seen in my career. And I attribute a lot of it to the youth of Silicon Valley, although the origins of Hadoop were actually gray-headed guys like me. So, all right, and with that, then I am going to say fini and open for questions there, Anthony.
All right, very good, Dale. Excellent presentation. I really, really enjoyed it, and I've got lots of questions here. Just want to remind everybody one more time that the slides are not proprietary and confidential, and that you would go ahead and Dale, I suppose, use them as folks see fit and leverage them to educate?
Yep, whatever they want to do with them, please do.
Okay. First question that's come in is a technical question. How does the Hadoop environment affect bandwidth requirements? What are you currently running to be able to handle 1 terabyte of data, or I guess what do you need to run to be able to handle that data? Dale?
Yeah, well, that's a good question, and you know, gig backplanes are pretty important to all of this. So we haven't yet overcome that challenge with the throughput around networking. But one of the things that is interesting is in that MapReduce window, not everything is coming back through a single pipe. Right? So that's one of the good news, bad news about that MapReduce window is it's assembling the results of these queries through multiple feeds. So you're distributing not just the computing, but you're also distributing the result set through multiple feeds. So that's part of what makes it scalable from a networking perspective. But yeah, networking is still a problem. You know, it's significantly better in this infrastructure because of that MapReduce window. Okay,
very good. I suppose we can take current CIOs, divide them into a couple of camps. The first one would be Hadoop enthusiasts, and maybe the other ones would be Hadoop, I don't know, deniers or laggards or sort of status quo people in the middle, as you mentioned them. For the Hadoop enthusiasts, is the biggest challenge getting buy-in from the rest of the C-suite on sort of transitioning? What would a transition look like, both in terms of the underlying technologies, and then what may be the biggest issue are the people that you have? And you mentioned, you know, there's ways to transition your folks. There's educational materials. Can you teach an old relational dog Hadoop tricks? And that's a pretty good quote, so maybe I'll keep that. But anyway, go ahead. What are your thoughts on that?
Well, that is a good question. You know, going back to my comment that every C-level has to be a little bit CIO now, education about the underlying technology is, I think, really important. So I think the CIOs have to say, look, these are the things. For instance, if I were still a practicing CIO, I would find time on my other C-levels agendas to say, I'm planting the seed here. This Hadoop and NoSQL data environment is a real deal. And we've been talking about it for 10 years or so. It is now becoming a real deal. And it's becoming so compelling that we have to figure out a way to transition ourselves into this new world. But we have to do that technically, and we have to do that culturally with our skill sets. So I'd start planting those seeds of conversations right now, literally right now, you know, like starting today, because it's going to take a couple of years to put together the strategy for the transition. You know, one of the easy ways to get started and become familiar with Hadoop, you know, by the way, you can download Hadoop. It's open source. It's free, right? So there's no cost to start playing around with the Hadoop ecosystem. The only cost is, you know, the sort of the distraction of people as they learn it. But that's an investment, right, not a distraction. So get a Hadoop environment set up and let your data analysts, let your technical team start playing with it. You don't even have to download it, right? You can get it now in the cloud. Amazon will give you access to Hadoop clusters. Google will. Microsoft Azure will. So you don't even have to have any infrastructure if you don't want to do that. You can access and start playing around with Hadoop in the cloud. And then, you know, as far as scheduling kind of the transition of skills, it's going to be interesting, friends, because SQL programming is still going to be useful and valuable in the Hadoop world, no doubt about it. And these translators that sit between the Hadoop ecosystem and the SQL programmers that you have is getting better and better. So you can issue SQL commands, have it go through these translators, and the result sets are getting you know, more and more accurate. I mean, frankly, Hadoop didn't support ANSI standard SQL very well for a long time. That's changing because everyone understands there's no way we're going to throw away the huge investment we've made in SQL skills. Just can't do it. That said, you know, so your SQL programmers and your SQL query writers will always be valuable, but it's a little bit like what I think those of us who were around watched the transition from COBOL programming to you know, object-oriented programming, for example, from Fortran programming to C++. It's tough, right? Moving from a SQL programming environment to a procedural language is not easy. Some folks have both skill sets, right? But Java, to some degree .NET, Python, those are the programming environments of the future around data analysis. We're moving towards a world of algorithms becoming more and more important. The good news about that is the cloud-based services are now giving us access to machine learning algorithms that we never had before. So in the past, you'd have to have a team of data scientists, you know, crunching away with these algorithms and trying to figure out how to build these in-house. But the cool thing now is IBM, Oracle, Microsoft, I think Amazon now is opening up and giving you access to machine learning algorithms in the cloud that you can submit your own data to. So it's just fascinating, right? This transition is not going to be as hard technically as what we went through from, you know, in the COBOL, Fortran world into the object-oriented world because of this commoditization of the skills. So I think I'll stop rambling with that.
That's good stuff. We're going to go a little long today, folks, because I've got some more questions for Dale. So we'll go about another 6 minutes and let you get to your meetings on the hour. Next question that's come in, how do we marry this strategy with the more inline strategies around providing data real-time within the EHR? The biggest movement the biggest movements we see are with the big EHR vendors, for example. How do you think this will play out over time? Can you grasp that enough to get an answer out, Dale? It's a little.
Yeah, you know, I wish I had more faith in the current software engineering architectures of the major EHR vendors right now, because I don't. I'm a little cynical, but I'm hopeful, I guess. The reality is we have to start peeling back these very encounter transaction-oriented user interfaces that the EHR vendors provide right now. We have to completely change that user interface and start embedding the kind of decision support that we had at Intermountain Healthcare when we had, you know, the help system, our own EHR, where we could do whatever we wanted to with the APIs and the user interfaces. And we embedded the knowledge from data in embedded decision support in this very ambient way. You didn't even know that your decisions were being affected by the huge number crunching that was going on in the back end. it guided you through better decisions at the HR user interface you didn't even know about, right? And so we've got to get the HR vendors to start doing that and peeling open these, Smart and Smart on Fire and Argonaut. Those are all great initiatives that I think offer that possibility. So keep pushing those agendas and keep requiring the vendors, to support those. But I go back to a paper that was written by some folks here at the University of Utah a few years ago that physicians are 15 times more likely to change their ordering behavior and follow evidence-based guidelines if you present them with substantiating data at the point of care versus in, a meeting over in the conference room where you all sit around a table and you decide what, evidence-based care for congestive heart failure is. Then you go back to the point of care with these EHRs that don't present you with the contextual information to make the right decisions about a patient, right? They have to remember everything from that conference room at the point of care. And what we've found at Intermountain is that, it's 15 times more likely for a physician to follow evidence-based guidelines if you give them substantiating data and surround them with decision support at the point of care. So that's the next great frontier that we all have to push and demand for. And Smart on Fire and Argonaut are great steps in that direction.
Very good. Next question. This may be our last one. I might throw in one more. How do you see the use of predictive analytics using Hadoop in healthcare?
Well, it makes it easier algorithmically because Hadoop and the whole Hadoop ecosystem were kind of set up to be manipulated with algorithms, right? So if you look at predictive analytics and eventually prescriptive analytics, they're really all about writing algorithms in procedural code of some kind, C++, C#, Java, Python, those kinds of languages. And so to that degree, Hadoop makes writing those algorithms more natural than the relational world. Now, that said, right, we write, procedural code and predictive algorithms around Microsoft SQL Server all the time at Health Catalyst. So you can do it. But Hadoop and the environment of Hadoop, and especially Spark, were set up around that algorithm mindset from the beginning. So it's more natural in those settings.
Very good. All right, final question, and this one's coming from me. I hear over and over again from the CIOs I talk to that they want to distance themselves from the technologies in a sense that they're responsible for. It's a very interesting dynamic. They want to be pulled into other departments. It's almost like they want to get away from the technology. So how do they have a conversation with a C-suite member about this kind of issue without going to the place they're trying to get away from, which I don't know why they're trying to get away so hard from it. Do you see what I'm talking about? Maybe you could just run with that.
Yeah, no, I get it, friend. I tell people all the time, as a CIO, the last thing that I ever want to do again is build or maintain a data center. The last thing I ever want to do is know the model of a server or the model of a storage array. I just don't want to know that anymore as a CIO. I want that to be a service, right? So my role, I think, going forward as a CIO is going to be brokering cloud-based functions and services, knowing where to go for those, how to manage those relationships and those services, knowing enough to evaluate and make a good decision about the technology that's behind the scenes, right? So that you know the pros and cons, right? I always say that I don't know programming well at all anymore, but I know the pros and cons of different programming environments. I know in general what you can and can't do realistically in those programming environments. Same thing with relational versus non-relational databases. I know the strengths and weaknesses of each. I know what you can and can't do realistically in each. And so as I evaluate the services providers as a CIO, I can make an informed decision about those at that level. But I really believe that the CIO of the future needs to start operating at the data content and the application layer more than the lower levels of the technology stack, and get away from the networks and the servers and the storage arrays and the desktops, and get up to the data content and the application configuration layer, and eventually the decision support layer, right, where this transaction data and this analytic processing are all going to come together. So, yeah, I totally agree with kind of distancing yourself as a CIO from the technology. I think is probably a good idea, but you have to, it's a little like a physician. If you don't have a basic understanding of biochemistry and physiology, you can't be a good physician. If you don't have that basic understanding of underlying technology, software engineering, data engineering, network engineering, that kind of basic concepts, you can't make those pros and cons decisions about the services that you're going to purchase in the future. You don't necessarily have to manage them anymore, but you have to know how to make an informed decision. So that's my thought on that, friend.
Well, I think that's a great answer. That's about all we had time for today. I can't thank you enough, Dale. That was an incredible educational session, and I learned more than I've ever known about the topic. So thank you. I want to thank Health Catalyst, it's the truth, for sponsoring the event. As I said, you'll receive an email as soon as our archive has been posted to YouTube. For those of you who hold the CHIME CHCIO certification or attending our webinars gets you 1 CEU. If you've asked us to let CHIME know of your attendance, we will. If not, make sure you let them know. Sponsorship opportunities for events like this, contact Nancy Wilcox. General questions and comments, you can contact me, and you can go to our site to view our upcoming schedule of events. So once again, I want to thank Dale, I want to thank Health Catalyst and our attendees, and everybody have a wonderful day. Thank you.
Thanks, everybody.